right, let's get started. Good morning, everybody. Welcome to this session on data encryption and integrity, the innovations in Azure SQL. I'm going to talk about encryption and integrity of your data. I hope you will understand it. Sometimes it will be hard, well, difficult, but I'm here to explain it to you in an understanding way. My name is Pieter. I'm a program manager in the data platform security team at Microsoft. So my team manages all the security features in Azure SQL, in managed instance, and also in SQL Server. And I'm the PM for two features. One is called Always Encrypted, and the other one is Ledger. And these are the two features that I'm going to talk about today. Feel free to interrupt me if you have any questions, or if I go too fast, let me know. All right? Cool. So what's on the agenda? Two main topics. First of all, data confidentiality controls. Ooh, difficult word. So I'm going to talk about transparent data encryption, or TDE, and always encrypted. And then we're going to jump into a second topic, which is data integrity controls, and I'm going to talk about Ledger. All right. Now, what are the existing encryption technologies that we have? We have three of them. First of all, the one data at rest, which is called transparent data encryption. So everything that is stored on disk is going to be encrypted, right? I'm going to explain immediately a little bit more in detail what data encryption at rest is. Then we also have data in transit. That's transport layer security, or TLS. That's really the wire between your application and your server, your database, that we're going to encrypt. I'm not going to talk about TLS today. And then we also have encryption in use. So how can you encrypt data that is actually being used and that can be queried while processing, right? And that is always encrypted. So we're going to talk about transparent data encryption and always encrypted. Let's start with TDE. TDE, it's really, like I just said, it protects your data at rest. So what happens if SQL Server needs to write something to the disk? Before it is written to the disk, it's going to be encrypted, right? So we're encrypting it and then we're storing it on the disk. The other way around, if SQL needs to read something from the disk and needs to load it into memory, before it is loaded into memory, the SQL engine is going to decrypt it and it's going to load it in plain text in memory, right? So it means that everything that is stored in your data files is going to be encrypted. This means that your backup files, your transaction log files, so everything is going to be encrypted. The good thing about TDE is that it's transparent, so you don't need to change anything on your application side. You don't need to change anything in your code because everything is done by the SQL engine or by Azure SQL database. Make sense? Yeah? All right, cool. And in Azure SQL, so Azure SQL Database and Managed Instance, TDE is enabled by default. So from the moment you create a database, we enable TDE for you. You can disable that, but we do not recommend to do that, right? For the encryption keys, there are two ways to use an encryption key. So we have service managed keys and we have customer managed keys. I'll come back to that immediately in a couple of slides. So what is the key management? How does TDE work? So we have your Azure SQL database, and your Azure SQL database is going to be encrypted by what we call a database encryption key, or a DEK. So that is the key that's actually doing the decryption and the encryption to the disk, like I just explained, right? Now that data encryption key, is protected or is encrypted by what we call the TDE protector. And there are two keys that you can use: a customer managed key, or CMK, and the other one is service managed key. The difference between the two is service managed key is managed by Microsoft. So we manage your key, we manage your certificate, we do the key rotation on a yearly basis. So easy for you, you don't need to do anything. We just do it for you. Now, we got some complaints in the past from customers. They were like, yeah, but if Microsoft manages my keys, then they can also decrypt my data files. And I don't want that. I want to use my own keys. So that is now possible. So you can use what we call customer managed keys, or CMK. So you, the customer, manages the key. So Microsoft, we do not manage the keys at all. It's your responsibility to do the key rotation and to provide the key in the Azure Key Vault. Okay? Under the covers, what happens is, for Azure SQL database, so customers that have a basic tier, a standard tier, or general purpose tier, or hyperscale, we're using remote storage. And with remote storage, that storage is already encrypted. So if we enable TDE on top of that, so it means you actually have double encryption on your data files. Looking at the local storage, so business critical and premium edition, they are using local storage. So that's not encrypted, which means if you should disable TDE on a business critical database or a premium database, your data files are not going to be encrypted at all. So be careful with that. Yeah, so that's how TDE works. Now, previously for TDE, you had to enable that on server level, right? And all the databases got encrypted with the key that you configured on server level. Now, we had some ISVs and they were complaining like, yeah, but we have customers and they want to use their own key on a database level, but we cannot do that. We can only provide a key on server level, right? So we came up with a solution for that, which was released last September, and it's now database level configuration. So you can now choose between the two, or you can say, yeah, I just want to inherit the encryption on server level, or you can say, no, I want to use my own encryption key on a database level, which makes it more user-friendly for the ISVs. And on top of that, you can use cross-tenant key access, which means that, for example, your key can be in another tenant, the key of the ISV, for example. So that is also an advantage of using these customer-managed keys on database level. Let me quickly show you how this works in the portal. Where's my portal? All right. So I have here a database called Contoso HR Demo. And if you go to the portal and you click on data encryption, here you have the transparent data encryption setting. So like I said, by default, it is enabled. So my database is fully encrypted. And here you can choose between the two. You can say, oh, I want to use server level encryption key, or I can overrule this setting and you can specify database level customer managed keys, or CMK. When you do that, what you need to configure is you need to, first of all, configure a user-assigned managed identity for the database so that it can have access to the key inside the key vault. And then you need to select your key by changing your key here and going to your key vault and then select the key vault you would like to use. That's how easy it is. So nothing special. You just need to configure your key in your Azure Key Vault and then configure these settings on a database level. All right. Cool. Any questions? No. Okay. Now, TDE also works, of course, in SQL Server. You just have to enable it there, and it's the same type or the same principle that we have in Azure SQL DB. All right. Cool. Now, that was in short TDE. Let's jump to the other encryption technology that we have, and that is called Always Encrypted. Are there any people in the room that are already using Always Encrypted? Nobody? Okay. Do you know what it is? Yeah, a couple of people do. All right, great. Now, let me explain what it is. So what was our motivation? We wanted to help our customers to enable, we want to enable our customers to store sensitive data in the cloud, right? But we also wanted to protect that information from malicious insiders or high privileged users. And to give you an example, in my previous life, I was a database consultant. So when I came to my customers, I typically got a lot of permissions on the database systems. So I could easily do select star from table, blah, blah, and I could just retrieve all that information, right? If it was not encrypted, even if it was sensitive information, I could see that. I could even make a copy of it to a text file and bring it with me. So sometimes your databases, they contain sensitive information and you don't want to expose that to everybody, right? Only the people that needs to have access to that encrypted information should see that information. And that's why we came up with Always Encrypted. And on top of that, so the DBAs, they should still be able to do their work, but they shouldn't see the data, right? But we still wanted that the query engine still can process on that encrypted information, right? So we came up with the first version of Always Encrypted, and we started our journey in SQL Server 2016. So that was the first version. It is also available in Azure SQL Database and in Managed Instance and also in Cosmos DB, right? So how does it work? Everything here in this box is client side. So that is your application and is considered as trusted. So everything that happens inside your application is trusted. Everything outside your application, meaning the network, the database engine, me, the DBAs, the external consultants, so everybody else is considered as non-trusted and shouldn't see the data, right? So how does it work? Your client application is requesting information from the database, right? So it's sending that query in plain text to the client driver. The client driver on the application side is going to encrypt that information and is going to send it in ciphertext over the network to the database engine. The database engine knows that encrypted information. It will retrieve that encrypted information and is going to send it back to the database engine, again, in ciphertext. And it is the client driver here that is then going to decrypt that information and is going to show it to you in plain text inside the application. Again, everything inside the box, inside your application is trusted. Everything outside is considered as non-trusted. Make sense? Everybody still with me? Yeah, all right. So that was our first version. The problem was that you lose a lot of flexibility. And what I mean by that is you could use an encrypted column in a where clause, but you could only use equality. So you could say where encrypted column equals a specific value. But you couldn't say like, or you couldn't do larger than, smaller than. So you were quite limited in functionality of using encrypted columns. On top of that, you couldn't use joins, you couldn't use group by on encrypted columns. So first version, pretty good, but we were quite limited in functionality. So we wanted to address these problems, and we came up with a second version of Always Encrypted, which is Always Encrypted with secure enclaves, right? That was released in SQL 2019 and is still available in SQL 2022, and we also have this available in Azure SQL Database. The principle is exactly the same, so you can still see the box, but the difference now is that the database engine can use an enclave. Now, an enclave is a trusted memory environment inside your SQL Server or inside your database where nobody has access to. No operating system administrator, the SQL process doesn't have access, no DBAs, literally nobody can access that secure enclave, right? So what happens if the SQL engine needs to do computation on an encrypted column? It's going to delegate that computation to the enclave, which means that inside that enclave, we can safely decrypt that information, do the computation, and then encrypt it again, right? By leveraging that enclave, it means we get much more flexibility now, right? So we can now do rich confidential queries, which means we can now do larger than, smaller than on an encrypted column. We can do like on an encrypted column. We can group by on an encrypted column. We can even create an index on an encrypted column, which was all not possible in the first version of Always Encrypted. Yeah. On top of that, in-place encryption is another advantage of using the enclave. What is in-place encryption? Let's assume that you need to do, or you want to do an initial encryption of a specific column. In the first version, what we had to do is we had to extract all the data from your database to the application side, do the encryption, and then push everything back in. It was not really secure, and it was also quite slow, especially if you have lots of data that you need to extract. Again, by using that enclave, that is not necessary anymore. Your data can still stay inside of the database, and we're just using the enclave to do the initial encryption. The same for key rotation. Your data can stay inside of the database. There's no need to extract anything out of the database. All right? Any questions before I continue? Yes, sir. I can also repeat the question, yes.
Okay, so what's the performance cost of using a secure enclave?
What is the performance cost? For using a secure enclave, there is no performance cost. The cost is in the client driver, because that is the driver is doing the encryption and the decryption, not the SQL engine. The SQL engine is just doing the computations, just like on a normal column. Yeah, but you will definitely hit performance issues. It depends on how much data you encrypt and how many columns you encrypt. Yeah, and how big your data is. But it is the client driver that is doing all the work. I can assure you, you will see some performance degradation if you use encryption. Yeah, that's the penalty that you pay of using an encryption technology. Okay, but using an enclave doesn't have any influence on the performance. All right. Other questions? No? Okay, cool. So what are enclaves in Azure SQL database? And we have two types of enclaves. We have Intel SGX enclaves and we have VBS enclaves, or virtualization-based security enclaves. The difference between the two is the following. So Intel SGX...
There is a question online, can I ask?
Yeah, sure.
As a DBA, can we still easily analyze query plans with cached parameters?
Yes, you can still do that. So the DBAs can still do their work. The only problem will be that the value of the parameter they will never see. It will be encrypted values, of course. Yeah. So as long as you don't have access to the encryption key, you won't see the data. And that's the whole purpose of always encrypted. DBAs, sorry, you don't need to have access to the encryption keys. Okay. All right. Back to the enclave. So we have two types of enclaves, hardware and software. Hardware is Intel SGX. So if you want to use Intel SGX, you need to create a specific type of database in Azure SQL called the DC series. And when you configure a DC series, under the covers, we're going to create a virtual machine that is using a specific CPU, an Intel SGX CPU, that can guarantee the security of that enclave. Yeah. VBS enclave is software-based, so it's just a Windows setting under the covers that we switch on. So there is no hardware dependency there, right? Now, if you look at the difference between the two, you can already see that we have a limited amount of vCores. We can go up to 40 physical vCores, so 40 of these Intel SGX CPUs, while with VBS enclaves, there's no limitation. So the maximum now is 128 vCores. Regional availability, we only enabled the largest Azure regions. If you want to use Intel SGX in the region, we don't have it for the moment. Contact me, I can enable that region for you. Well, not me, the engineers can do that. So where's the difference? What should you choose? Should you go for VBS enclaves or should you go for Intel SGX enclaves? And as always in SQL, it depends. And it depends on from who you want to protect your data. If you're saying, oh, we just need to protect the data from malicious insiders, from the DBAs, from the consultants, fine. Then you can easily go for VBS enclaves. But if you have higher security requirements where your security department says, we don't trust Microsoft either, right? So, which means at that point, you will need to use SGX enclaves. And the reason is that VBS enclaves do not protect you from attacks from the host OS. Microsoft, we are hosting your database, so it means that we potentially could get into your data. If you don't want that, so if you don't trust Microsoft, then you need to go for Intel SGX. That's the difference. Another difference is VBS is completely for free, so you don't need to pay anything extra. Intel SGX is slightly more expensive compared to just a normal database. Okay, cool. Enough theory. Do you want to see that in action? Yeah? All right. So my demo is I'm going to use an Azure SQL database that is using VBS enclaves. Make sense? Okay. So first of all, let's go to the portal. I have a database called Contoso HR Demo. And if I go to data encryption and I go to always encrypted, I can see that my enclave is enabled and I have a VBS or virtualization-based enclave enabled. That's the first step that you need to do. Great. Now, I also going to use a key vault, and my key vault is going to store my encryption key, right? So I go to the key vault, here under keys, I have one key which is called CMK. CMK stands for column master key. And a column master key is going to protect a column encryption key, and a column encryption key is going to do the encryption of my column. I show it immediately in the management studio. What is crucial here is the permissions on this key. What should have permissions are the people that can have access to your data or can see the data, right? So in my example, my application has access to the key, and my Windows account also has access to the key. Nobody else of Microsoft has access to this particular key, okay? What else I'm going to use is a web application, and this is the web application. It's called Contoso HR Employees. So it's used by an HR department, and as you can see, it contains quite sensitive information. So social security number, first name, last name, and salary, right? So if you don't need to see that information, we should encrypt that. All right. So let me go to the management studio, and if I just do a select statement here, you can see, or I can see exactly the same data. Is this visible in the back? Yeah, okay, cool. All right, so what are the first steps that you need to do? You need to start with configuring your encryption key. So you go to security, always encrypted, and the first thing that you need to do is you need to configure your column master key. I've already done this for demo purposes. And what you need to do here is you need to store the location of your key. So the key that I've just showed you in the portal, in the key vault, this is stored here. To be clear, we're never storing the key itself inside the database. We're just storing metadata that is pointing to the location of the key, right? So that is really crucial in this part of always encrypted, just the metadata. All right, so we've configured the column master key, and then once you've configured the column master key, you need to configure the column encryption key, or CEK. And this, the column encryption key is protected by the column master key that I've just created, right? So these are the first step, configuring your keys inside your database. Now we're ready to do the encryption, and there are several possibilities to do. You can use T-SQL statements, you can use PowerShell, or we also have in the Management Studio a nice wizard that we've implemented that help you to make it easy to encrypt your columns, and that's what I'm going to use. So if you right-click on the table, then you go to Encrypt Columns. This is just an introduction. First thing that you need to do is you need to specify the fields. Well, let me go for social security number and salary, and then you need to specify your encryption type. And we have two possibilities, deterministic and randomized. Does anybody know what the difference is between the two? You do, sir? Can you tell me? Yeah. Yes.
Okay. Deterministic, the same value give the same hash. Randomized, the same value give the different hashes.
Correct. That's right. So if we're both, our first name is Pieter, for example, and we choose deterministic, the encrypted value or the hash will be exactly the same. If you choose randomized, then the encrypted value or the hash will be completely different. So randomized is a little bit, it's not a little bit, is a stronger encryption type compared to deterministic. If you want to use enclaves, and that's what we want to use, you always have to use randomized. So you cannot use deterministic. Otherwise, you will use the always encrypted version. Okay. Oops. So let's go for randomized on both of them. Click next. Yes, sir.
I can choose different key for the different column?
Yes. Yes. Now for demo purposes, I will repeat the question. Sorry. The question was, can I use different keys for each column? Yes, you can do that. So you can configure multiple column encryption keys on several columns. For demo purposes, I'm just using the same key. Cool. Master key, we don't need to do anything because we've already configured our master key. Yes, I want to use in-place encryption. I'm going to proceed and finish this right now. You just get a summary of what we're going to do, and then we just click finish. This will just take a couple of seconds to finish. There we go. The reason why it takes a little bit longer here is because my subscription or my account is member of lots of subscriptions. So it needs to validate all these subscriptions before it can actually start the encryption. But in the meantime, we have a question. Sure.
Am I right? When we want to use joins, let's say we should use encryption type deterministic. Is it true? Am I right or
If you want to use joins,
yes.
It depends on the version. If you want to use joins with enclaves, you can use randomized.
Ah, okay.
But if you just use always encrypted, then you need to use deterministic. That's correct.
Okay.
Okay. Other questions? Till we wait till this is finished. There we go. All right. So encryption is done. It means that if I run this same query again here, and this is, I'm connected with an account that doesn't have access to my encryption keys. If I run this again, you can see here that social security number and salary are completely encrypted. So ciphertext, you cannot read anything whatsoever. If I go back to my application, and I just do a refresh here, my application has access to the keys, so it is completely trusted. When I do a refresh, it just takes a couple of seconds to reconnect. Hopefully it reconnects. Bear with me. There we go. So the application can still see the sensitive information. Why? It has access to the keys, so the client driver can actually do the encryption and the decryption of that information. Yeah, and we can still search on it. So if I go here 99, which means under the covers we're using like on social security number, that actually works. If I go back here to my SSMS, and this is a query window with my account connected, so I'm using the same here, using like, I can still see that sensitive information. Okay, questions? Pretty cool, right? Now, if you want to convert an existing application to use always encrypted, what are the steps that you need to do is you need to upgrade your driver, because not all the drivers support always encrypted. We have it documented, so most of the, everything .NET is supported, ODBC, GDBC, and what was the last one? I forgot. Anyway, it's documented. So you need to upgrade to the drivers. You need to change your connection string. So you have to tell your application that it has to use always encrypted. So there is an extra setting called column encryption setting equals enabled. And then you tell your application that you need to use always encrypted. And then lastly, which is really important, like I did here in the management studio, you always have to use parameters for your encrypted columns. So you cannot use literals. I cannot say like and then %9838. That's not going to work. So you always have to use parameters in your queries. Okay? Cool. By the way, this is all available also in SQL Server. So I've heard that people in Poland, they're really still into SQL Server. So is that correct? Is that true? Yeah. Well, always encrypted with enclaves, like I said, it's also available in SQL Server, not only in Azure SQL Database. All right. Yeah, some marketing stuff now. Well, no, not really marketing. So these are customer cases of customers that are using always encrypted. So I've closely worked with these customers together, and we've created a customer story about it. So if you go to that URL, you can read the story and why they're using always encrypted. So this one is for Royal Bank of Canada, and the other one is Loyal Health. Loyal Health is, they have implemented an application. It's a US company, and they've implemented an application that is used by hospitals. So their application contains patient information and all that sensitive information. So they are one of our largest customers that are using always encrypted. So if you want to learn more about their use case, again, go to that website, aka.ms loyal case study, and you can read all about their story. Okay? All right. Last topic for today is, so we've talked about encryption, Now we're going to talk about data integrity. And what I mean by data integrity is how can you be 100% sure that all the data inside your database can be fully trusted? Again, I was a SQL consultant. I can go to my customers. I have access to the databases. I could easily do update, blah, blah, set column to a specific value. Nobody would have ever noticed that I've done that, right? There were solutions like auditing, but then auditing, if I had system administrator permissions, I could just easily disable the auditing, do my tampering, and then enable auditing again. So we didn't have any solution to help our customers, and that's why we came up with Ledger. Ledger is available in Azure SQL Database, Managed Instance, and SQL Server 2022, not in SQL Server 2019. And we're also not going to backport it to 2019. So the idea is to establish trust, right? And to help our customers to prove to external parties, to auditors, to regulators, that your data can be fully trusted. And what we're going to do is, under the covers, we're using a blockchain technology to provide cryptographic proof to our customers. So we're going to cryptographically going to link all the changes that are being made on ledger tables. And we're going to link those together just like in a blockchain mechanism. I'm going to explain it immediately in the next slide, how it works. The good thing about Ledger is it is SQL. So if you already know SQL, it's very, very easy to use Ledger. It's just you need to configure a Ledger table, and that's basically it. All the rest, all the integrity is done by Microsoft or by the engine itself. Yeah. What are the use cases? Like I've already mentioned, we want to help you to streamline your auditing. So if you have external auditors and they're telling you, can you prove to me that this data can be trusted? In the past, you had to go over it and build in your own mechanism and use auditing and stuff like that. Now with Ledger, you can just run what we call a verification procedure that is going to verify the integrity of your database. And if that is successful, it means that you have cryptographic proof that your data can be trusted. Another use case that we see is multi-party systems, or for example, supply chain, where you have different suppliers, but the database is centralized. That means that all the different parties should be separately be able to verify that the data can be trusted. So what do we call it? The database is centralized, but the trust is decentralized. So these are the use cases for Ledger. Yeah. Let me jump a little bit more into detail how it works. We have the concept of ledger tables, and we have two types of ledger tables. We have updatable ledger tables and append-only ledger tables. Updatable ledger tables allows you to do insert, update, and delete statements. Append-only, we block update and delete, so we only allow insert statements. Yeah. So how does it work? When you create an updatable ledger table, under the covers, we're going to create a history table, which has exactly the same schema like your updatable ledger table, but on top of that, we're going to add some extra metadata, like username, commit time of the transaction ID, and stuff like that. But for the rest, we have the same schema of your updatable ledger table. On top of that, you get a ledger view, and the ledger view is a combination of your updatable ledger table and the history table. So it gives you a chronicle overview of the values of your records. Now, people that are familiar with SQL in the room here, they're probably going to tell me now, but yeah, Pieter, we already have that. It's called temporal tables, right? True. Ledger is based on temporal tables, but temporal table doesn't provide you that cryptographic proof, and that's the difference. And that is why Ledger is different compared to temporal tables. So this is how we keep track of the history, right? If a user is doing an update on an updatable ledger table, what we're going to do is we're going to store the first version of that record in the history table, and then we're going to update that record in the updatable ledger table. So that's how we keep track of the history. Now, where do we provide that cryptographic proof? And that is done with what we call the database ledger. So every 30 seconds, we're going to encrypt with the SHA-256 encryption mechanism all the transactions that have occurred on the ledger table. And we're going to link these transactions to the previous transactions. So we're generating a block just like in a blockchain, and we're going to link it to the previous block. That is done every 30 seconds if you enable it to do it automatically. The customer itself, they can also generate these blocks manually, but we recommend to do it automatically. So you just, like almost every 30 seconds, we're generating a new block for you and we're linking it to each other. That's what we call the database digest. Everybody still with me? Yep. Now, once we've generated that digest, what we're going to do is we're going to offload that digest to trusted storage. And what do we consider as trusted storage? That is an Azure storage account with the immutability setting switched on so that nobody can tamper on the storage account. Or we have another service which is called Azure Confidential Ledger. That is another service that we can also use to store these digest files, right? Question?
Does any table from the database, is the ledger of the table a default value for it? Or if we have an older database that we migrate to 2022, can we update the table for it to become the ledger table?
Yeah, good question. No, you cannot. So you cannot convert an existing table to a ledger table. What you need to do is create a new ledger table, an empty table, and then we have configured a specific, or we created a new store procedure that can move all the data from your old table into the ledger table. Also the other way around. Once you've created a ledger table, there's no way you can convert it back into a regular table. That's something we do not support. All right, cool. Other questions? No, okay. Let me continue then. So we've offloaded these digests to trusted storage. And now it becomes interesting because an external party, what we can do now is we can fetch those digests from the digest storage where we have the hashes. And what we can do when we want to run a verification, we take these digest files on one side, and then in real time, we're going to recalculate the hash of the database, right? And then we're going to compare these two hashes. And if we have if these hashes match, then we have actually cryptographic proof that the data can be trusted. Nobody has tampered with the data because the hashes are correct or are matching. If they do not match, then we also have proof that somebody has tampered with the data. Could be with the digest files, but it could also be that somebody actually tampered with the data inside the database. To be clear, tampering means an update statement or insert or delete statement that was done not through T-SQL. So if you just to delete from a specific record, for a ledger table, that is just an ordinary transaction. It will be stored in the history table, but is not considered as tampering of the data. Tampering is really going into the data files and going around SQL Server to tamper with the data. Make sense? All right. Append only, you don't have a history table because we don't need to keep track of any history information because we don't allow update and delete statements. Customers that are using append only are using it mainly to store audit logs. So they have like a web application that has logging information. So typically you just need to insert it and never need to update or delete anything with regards to log files. Yeah. All right. Some customers that are using Ledger, where I have worked closely with, so different types of industry. So RTGS Global is in the financial industry. Lenovo, probably everybody knows Lenovo. That's a really interesting case. So what they are using Ledger for is when they configure a laptop, they store configuration parameters in a Ledger table. And the reason why they're doing that is when you order a laptop, they want to be sure that the laptop that you receive is actually the laptop that you have ordered. And this is real life. So apparently in between the Lenovo factory and you, there are vendors in between. And sometimes they just open up your laptop, they change the CPUs, they change the memory, and then they send it to you. Now, the first time that you boot up your laptop, Lenovo is going to check if these parameters are correct. So that information needs to be trusted, and that's why they were using Ledger. Last one is Code. It's a customer in South Africa, and they have used Ledger to store, back in the days, the COVID vaccination status of everybody in South Africa. So that was also stored in Ledger tables. So these are 3 case studies. Again, you can go to these links and read more about it. All right? Do you want to see that in action? Yeah? For this demo, I'm going to use SQL Server, so not Azure SQL Database. So I'm running locally on my laptop SQL Server 2022. Maybe some context. We're in a hospital called Contoso Clinic. And for this demo, there are 4 people involved here. We have Christina. She had a knee surgery, and as you can see, she's in a lot of pain. Then you have Betty. She's the nurse in the hospital. Then we have John, he is the DBA in the hospital. And then we have Michael, he's the external auditor. Yeah. So what happens? Christina, she's in a lot of pain. And she's, no, let me start over again. The hospital is using an application called Patient Hub. And that stores all the medical information of the patients. Now, Christina here, she's in a lot of pain after the knee surgery, and she wants to have some refills of Vicodin to how do you say that in English? Ease the pain? To ease the pain. Right. So she calls the nurse, Betty, and Betty says, yeah, sure, I can give you some extra Vicodin. So Betty also opens the same application. Where is it? Here. So this is Betty that is logged in. She goes to the record of Christina here. She goes to the Vicodin, and we're going to do a refill from 1 to 4, and then we're going to update the medication. It was successful, so Christina is happy. She has more Vicodin, so she has less pain. Now, under the covers, these medications, we're using an updatable ledger table. So you can see that also in the Management Studio. If you configured a ledger table, then it will say that it is an updatable ledger table. You can also see that there is a history table, right? Like I've explained, and there was also going to be a ledger view here. Okay, now, if we run this particular query, so I'm using here the ledger view in combination with a new system view called database ledger transactions. And then I'm going to fetch the history information. So what you can see here is the commit time of the transaction, the user that has executed that particular transaction, and then the records that have been updated. Now for an update statement, we're storing 2 operations. One delete operation, which is the old version of the record, and then an insert statement, which is the new version of the record. And as you can see here, the refills, they changed from 1 to 4, right? So this is just a normal T-SQL update statement. There is a question online.
Yes. Did the ledger tables store the full previous row or just the changes?
They store the complete record in the history table. But as you can see, they just change, or we store the different values, like the old version, delete statement, and then the new version with the new values. But we store the complete record every single time with extra metadata, as you have seen, commit time, the user that has executed transactions, and so on. Okay, cool. Now, Michael, our external auditor, comes in and he's just doing a routine review of the changes. So he's going to execute that verification store procedure, and that's called SP verify database ledger from digest storage. So I've configured my database to store these digests automatically. So when I run this, there we go. It gives you the following. So ledger verification successfully verified up to block 3. The number 3 is quite low, of course, because this is a demo database. I don't have much transactions here. But yeah, the ledger verification succeeded. So when you get this, you actually have that cryptographic proof that the data can be trusted, which is good. All right. Now, Christina, she's still in a lot of pain after a couple of weeks, and the nurse refuses to give her more refills, right? But John, the DBA in the hospital, he's a friend of Christina, and she asked him for a favor. And he's like, yeah, sure, I can do an update statement in the table. Nobody will notice that. But John is smart, and John sees that that table is an updatable ledger table. So he's like, yeah, but if I'm going to do an update statement, they will catch me because it's going to be locked in the history table, and I don't want that. So John is a really smart database DBA, sorry, and he wrote a stored procedure that can tamper with the data directly in the data files. So we're not going to execute any T-SQL statement. We're just going to change some pages in the data files. So what is John doing? He's going to look up the record that he wants to update, and it's going to be order met ID 2, which is indeed the refills is set to 4. So the stored procedure that he wrote was SP tamper with medications, and the number of refills, we're going to change it from 4 to 20, right? So let's do that. That's done. So if we run this select statement again, we can now see that the refills is set to 20. So I didn't run any update statement, right? I just tampered with the data files directly. Now, if I go to my application here again, and if I log in, Christina, password 123, you can see the refills is 20, right? If we should look into the history table, there will no trace whatsoever, all right? Okay, so John is happy, Christina is happy, everybody's happy. But then Michael comes back again, and he's running the same stored procedure again. And what happens now is the following. So that stored procedure doesn't give me a successful back. No, it tells me the following. The computed hash from medications and the associated history table does not match the hash persisted in the ledger transactions for transaction ID 7433. So this gives you cryptographic proof that somebody has tampered with your data, right? And it says also, yeah, ledger verification failed. So now you have proof that somebody tampered with your data. What you can do next is you can take that transaction ID and look it up here. And it will show you that this specific record was updated. So you can see the refills were set from 1. So you can, here you can actually see which record has been tampered with, or records if there were multiple records. You cannot see, of course, who tampered with the data, but at least you know that something is wrong with your data and that it cannot be trusted anymore. The question that I always get is, how many times do we need to run that verification stored procedure? And as always, it depends. It depends on what is your priority. Do you want to run it like on a daily basis? Fine. Do you want to run it on a monthly basis? Also fine. Now, if you find that somebody tampered with your data, the only way to get your data back trusted is restoring a backup. There is no other option than get your trust back than restoring your database. Any questions? Sir.
So if you rerun the verification procedure once again now, will it still fail?
Yeah.
So what is the solution? Let's say that we figure out what happened, the DBA got fired, etc.
Yeah.
We fix the issue.
The solution is to do a restore of your database until the point where you know that the tampering was done. That is your only option that you can do. There is no other way to fix that. I'm sorry?
The whole database, not the table only.
The whole database, yeah. We cannot restore tables in SQL. So you just need to restore the whole database.
Okay, the second question.
Second question.
Can we see the stored procedure executed by the DBA?
No.
Thank you.
I'm not allowed. Well, you've seen a little bit of it, so you can. I'm sorry. Yeah, I cannot share the way I tamper with the data, unfortunately. No. Good question, though. Sir.
I have a question about this update table, ledger table. What if I would like to alter this table, add columns, remove columns, change the type, and so on?
Yeah.
Is it possible or not?
Yes. Yes. So the question is, can I alter an updatable ledger table? You can. So you can add columns without any problem. You just need to make sure that they're not nullable. Otherwise, it is not going to work. Removing columns is also possible. The problem with removing columns is that we cannot physically remove these columns because we still need that information if we want to run the verification, right? So you will notice that there is a system view called dropped columns. So physically or logically, the column will disappear, but physically we still have that data. I'm sorry? They still exist on the same pages. Yeah. Yes. Updating a column or altering a column is also possible, but it needs to be in the same data type. So you can say var character from 50 to 100, for example, that's going to work, but you cannot change var character to integer, for example. That's not going to work on a ledger table because we need that information, that metadata also to generate the blocks. So there are a few limitations, but most of them are possible. Yeah. Sorry. Yeah. If you use DBCC write page, read page. Yes, yes. You can still see the data. Yeah. Yeah, but that is, well, that's the type of table. It's a ledger table, so we still need that information. So I get your concern. Your concern is that your table will continue to grow and you will never be able to remove data, right? We cannot do delete. Well, if you do delete from a ledger table, we still store it in the history table. Logically, it doesn't exist. Physically, it still exists. Yeah. I get your concern, and it's a concern of lots of customers. So they want to get some, I don't know, retention periods to remove old history information, for example. The problem is that it's not that easy to remove records from a ledger table because we still, from a history table, because we still need to have to generate that same block, right? And we used all these transactions too. So yeah, it might be easy to say, yeah, just implement a retention period, but it's not that easy to do. So, but I get your concern. Yeah. Other questions online?
Yes, there is a question about second example of John manipulating data. What if sometimes the business wants this operation from John, then John completed business task, but audit show problems?
Can you repeat again, please? Sorry.
Yeah, no, so it's about second example with John manipulating data. What if sometimes the business wants this operation from John, then John completed business task, but audit shows problems?
If John needs to do that update statement from the business side, then he will just generate an ordinary update statement, right? Which means that will be tracked in the history table. So if John has, I don't know, got an email that he can prove that he had to do that, then again, the verification store procedure will not fail because for Ledger, this is just a regular update statement, right?
Okay.
So that's how it works.
Okay, there is another question. What about GDPR?
GDPR, yes, that is also a concern. Same question or the same problem. If we drop columns and you have GDPR regulations that data has to be removed, unfortunately, you cannot use Ledger. Yeah, there is no option to do. Yeah. Question? Two questions. Performance. What about the performance? In the meantime, I will repeat the question. Performance, there is a slight impact because for every update statement, we need to write 2 records to the history table. Yeah. We did extensive testing. We have a white paper on Ledger where you can verify all our performance tests and how much performance degradation that you will get. All the customers that I've worked with, they never complained about performance problems using Ledger tables. So yeah, You will have some slight performance depending on the number of update statements that you need to do.
The second, what about the encryption data in the ledger table?
You can combine always encrypted with ledger. That is possible. Yeah. Then the information will be encrypted as well in the history table. Yeah, that is possible. Okay. All right. I have 5 minutes left, so we're right on time. So to wrap up, what have we seen? Two main encryption technologies that we're using: TD, transparent data encryption, security at rest. Always encrypted is encrypting data that is in use. We have seen how you can configure that. And lastly, we have showed you how Ledger can help you with providing data integrity on your database. Yeah. Thank you to the sponsors. And I thought, oh, I'm missing a slide. I will add it to the slide deck. So I have a bunch of links with resources. So documentation of Ledger, documentation of Always Encrypted. I have a bunch of blog posts. The demos that I have used are on GitHub. So if you want to play with it, except for the store procedure. But if you want to play with it, with Ledger or with Always Encrypted, I can also share you that link. It's on the SQL Server samples GitHub repository. You just get to set up scripts. You get everything from me. The same website, the Contoso website, so you can play around with it yourself. All right. Thank you so much for joining my session today, and enjoy the rest of the conference.